Squash, right? Look, it's just a type of squash. Cool. Pumpkin, indeed. Although it's November now, so maybe I don't know. Pumpkins are still.
Thanksgiving.
What about it?
Pumpkin.
Okay.
That makes sense. I'm not a huge fan of pumpkin pie.
Turkey.
Gobble. Cool. All right. There's an easy issue that happens here, and if you haven't seen it yet, we're gonna see it. I'm gonna do this piece by piece. Now, you will hopefully by the end of the day be able to look at a big, terribly ugly expression, and you can do it just bam, and you're done. But it takes a little bit of practice to get there, and if we highlight the mistakes that people make along the way, we'll avoid them. Quick check. Before I told you this was wrong yesterday, how many of you had this? Almost everybody. We're going to address that here in a second, just so we have them, and I moved where this was. Two things. First, here's the properties, right? These are the ones we're using. Product, if the argument's a product, then the logs plus, right? Product, the logs change to a plus. If it's division, the logs become a subtraction. And if it's a power, we just move it out front. I know that we spoke about it. I've said like a million times here. Here's what proofs turn into at your level, just so you know. Oh my gosh, I can't stop. You don't have to write this down, but I would like you to look at it. If we try to show a proof of the product property, for example, do you agree that for some numbers, u and v, there's log base b of u is something x and something y? Like those exist, yeah? When we look at this, if I just try to use uv then, and looking at it, just using the definition of a log, b to the x equals u, and b to the power of y equals v. Everybody on board with that? If I then write u times v, does this seem reasonable? This is what we get. B to the x times b to the y. We know exponent properties. Those change to adding. This, though, and I'm sure it's written in similar words, this is the definition of a log. We can change this exponential form into a log. So by doing so, b to some power equals uv. Here's that log form of it. All of a sudden, we just say, hey, this can be written here instead, but we already knew that it was x plus y. That's the exponent that we need. And then up above, we already said what x and y were. This is what a proof is. It's just logical, nothing crazy about it. I'm not going to expect you guys to write proofs now. We will, just so you know. Not like this, though. It's also not like your geometry ones. Random thing, did you guys have to write this in geometry? How did you know you were done with the proof?
You saw right.
Well, what if you have another proof to write afterward? You did what?
We wrote down a sentence.
You had, what was your sentence?
Like little brackets.
Cool. This is standard. The alternative is the letters QED. Quod erat demonstrandum. It's Latin for that which was to be demonstrated, which could be the sentence that you had to write. Okay. Does this seem crazy hard? Coming up with it yourself might be, but can you follow the logic that this uses? Proofs are easy. Don't let geometry ruin your idea of proof. Anyway, we're using those properties. I'm not going to say again all hour. Very intentionally. I've already said it 4 times since I commented on it. That does not surprise me whatsoever. Keep count. Hold me to it. If I say, this doesn't count, is it? If I say, what's a reasonable? Don't count it. What's a reasonable amount of times?
3.
Oh, 3?
Like 6.
Homework time! Just kidding. If I say it more than 5 additional times, what's the penalty?
No homework this weekend.
Ha, good luck with that. I can't do a push-up. All right. Here we are. It is a challenge. Cool. Let's take a look. I am going to break this up into small steps. It is unbelievably large amount of cognitive focus for me to avoid that sound. We will. I didn't say it, did I? Clearly, I want to. Much more challenging than I was expecting. Here we go. First thing that I recognize as I look at this is within the argument there's division happening. I would like there to not be division happening. There's a property that one can use to fix this. If I have division within my argument, what happens between their logarithms? They subtract. Rewriting this expression then, what should we obtain? You said natural log? Perfect. Natural log of W minus natural log of XY. Of XY. Doesn't count. There's no real prize yet, just for the record, which means make sure you're focusing equally hard on the mathematics as you are on my vocal patterns. Fantastic. Here's where the mistake happens. As we look at this expression, does anything else expand further? For sure, it do. Specifically, I see within this second logarithm there's a product, which means I can split this up. A product within the argument changes to the what of the logarithms? Addition. If you are not careful, however, mistakes happen. I get the natural log of W minus, check this out real quick. What was in the denominator? X and Y were both in the denominator, which means wherever that minus is, it better be connected to both of those to ensure that they wind up in the denominator. The way that I avoid this, I add these lovely brackets, and I hate that color. So rather, I add these brackets with a darker color. Oh my gosh. Natural log of X, then what? Almost. You missed a word. Plus the natural log of Y. In doing this with the brackets connected, the answer changes from the one that you likely had yesterday. One small little difference, but it makes a huge impact on the overall problem. What should happen with this negative?
Distributed.
It better distribute. We end up with the natural log of W minus the natural log of X minus the natural log of Y. This is easily one of the top two places where students make mistakes with things. Feel okay. Do you guys normally say it as well frequently, or are we just noticing, me specifically noticing, that you're doing it because you're also conscious of this currently as well?
It's one of those
Because as you say that phrase more and more, the desire for me to say that filler phrase more and more increases exponentially. Cool. I want you to do another one. You can show as much or as little work as you would like. I'm going to show you the amount of work that I typically do with these while working on a problem where this actually applies, applications involving calculus and the like. Does it feel as though I'm speaking unnaturally to you?
Yes. Just a little bit.
Yeah, it feels like you're like
Unbelievably bad. Cool. I want you to try one more. Much more formal, yes? One might say that my elocution is increased and sounds much more elegant and sophisticated. Professor Holloway, thank you. Charlie is for you. On a scale of 1 to 10, how difficult would you like this?
5.
By chance, how difficult would you have given this one on a scale of 1 to 10? This was an 8? Okay. I agree with Mr. Morris. Cool. I would like you to expand for me log base pi of xy to the power of 3/4 minus z, ooh, too hard, times z to the 1/4 divided by, I'm going to check your notational fluency with things you've seen previously.
What?
How many of you have seen sine squared before? Weird notation thing. I'll introduce it really quickly. We'll see it again, I promise. Checking out sine squared, just for your reference. If you were to take sine of theta and multiply this by, I don't know, sine of theta, this is sine of theta squared. Does everybody agree with that? However, this notation is uncomfortable for a lot of people. I don't hate it, but there's a better way. Typically with trig stuff, we will sneak that squared right there. 3 ways of writing the same thing. Cool. I want you to expand that. You'll probably employ this somewhere. Maybe not. We'll see. I want you to expand. I'm going to expand as well. However, I will not show near as much work as I hope you do. Cool. Do so now. First step, division. That's the first thing that I always recognize. Pretty sure that since I'm teaching you how to do this, you'll probably recognize division first as well. Beyond that, what happens inside of this argument of the first log? Multiplication. If I see multiplication within the argument, I can split it up into what? Addition of the logarithms. Cool. So lots of work going. I wind up with log base pi. What's the first thing that I multiply by something else? xy to the 3/4. If I write it like this, is it okay? No! Why? Right now, that 3/4 is only connected to the y. That's an issue. It's connected to everything. Sneak them in there. I wasn't really upset about it, just for the record. Cool. Plus, what? Log base pi of z to the 1/4 minus, and if I don't do anything else in this step, that's okay, log base pi of sine squared. Questions, concerns, compliments, insults.
That's not finished.
No. Cool. Anything else? Other property JV. Something else from this line moving forward. Oh my powers. What moves out front of this log? 3/4. Log of xy. What moves out front of the second one? Indeed it do. 1/4. Log base pi of z minus what moves out front of this? A 2. Because this sine theta was squared. 2 log base pi of sine theta. If we take little steps, my hope is that this feels a lot less ugly, but it's a lot more work. Anything else that you guys see I can do? I did. Thank you. Am I done? There's a hey, x and y are multiplying. Okay? 3/4. Now that 3/4 is connected to which? Both of them. 2 ways you can approach this. This is what I would do. If I just wanted to connect to both of them, whether we physically write it on them or not, I think that this does the trick. I'm using the fact that I know a b to the x becomes a to the x, b to the x. I'm using that exponent property. Only works if there's no addition or subtraction. Issues with that? Are we cool? I mean, I know I'm cool, but are you cool? Cool. Did I say it? Oh, thank goodness. Heavens. Minus 2 log pi sine theta. At this point, it is entirely up to you. I would take this answer. I'm good with this answer.
Why'd you put the log x and y in brackets?
So that the 3/4 is connected to both of them? I forgot something in this answer. I forgot the 1/4 log base pi z. Where should it go? After the bracket or inside the bracket? After. Cool. That's just a typo.
If you just write 3/4 in front of each of the log,
You could.
you don't have to put the brackets.
You do
in?
not. Nope.
Okay.
Plus 1/4 log base pi of z. That's my bad. Sorry, guys. Good catch. Minus 2 log base pi of sine theta. Now it looks okay. If you stop here, I'm good with it. If you had connected those, I'm good with it. When I expand this here in a minute, without showing all this work, we're going to get a different looking answer, but I promise it's not going to be different. Okay. You do not have to write down my short method. Some of you think this is super easy, I imagine. Some of you think it's super hard, and some of you are somewhere in between. You do not have to write this one down. This is what it looks like when I actually do this. I notice all of it at once. And like, not simultaneously, but as I'm looking, I think ahead. The 3/4 and the 1/4 come out. What I notice right off the bat is they both have a 1/4 in them. I could move the 1/4 power in front of everything. Whether I do that or not depends on the problem at hand. But check it out. Right off the bat, you guys saw the powers. You obviously see them. You see that there's multiplication. I'm just going to do it all at once. The 3/4 comes out, and it was from log base pi of xy. I already know it's going to connect to both of them. There's one step. I have just used both properties in one. Boom. I'm okay if you do it. The 1/4 also comes out. And I see that it's separated by multiplication, so I know it's addition. Plus 1/4 log base pi of z. The last one. What's the exponent on the denominator? A 2, and it's subtraction because it's quotient. 2 log base pi of sine. I intentionally give us the exact same answer. But if you understand those 3 properties, you can do them all at a single step. Word of caution. If you do this much work and you get it wrong, you get a lot of credit. If you do this much work and you get it wrong, you get how much credit? I would say a very little. Like 0, just for the record.
What's different about that?
Nothing. I intentionally did it the same, just so it would look the same. But the difference is the amount of work. I did this without thinking about any of the individual steps. We just did all the steps in one. No different than some of us take multiple steps to solve this equation. Some of us do 3 steps in one and get the answer. Same idea. Anywhere in between is fine. Cool. Well, we've gone one direction. We were expanding, yeah? Let's condense. And this is pretty close to the last example that we'll be working. Condense. Now, expanding simply means that we're taking a single logarithm with a single argument and we're writing it in a bunch of logarithms. We're just going the opposite direction here. And it turns out, exact same process, just other direction. So here we go. Let's start off with, I don't know, it's not going to be super hard. We'll try. I want the natural log. For the record, I'm going to use natural log, remember, 99% of the time. Log base pi was just to see if it could throw you off. Didn't change anything other than you had to write a little bit more. Natural log's easiest to write. I want to, just kidding, condense the natural log. Do you guys have room to write a 1/3 in front? 1/3 times the natural log of 3x minus 5 minus the natural natural log of y cubed plus 1. We are starting to kind of blur the line on where another common mistake happens. You know that you get subtraction when what happens within the argument? It has to happen within the argument. We don't have a rule anywhere that says if there's subtraction in the argument, change it to division. That rule does not exist. If it's division, it changes to subtraction. If you have two logs that are subtracting, the other direction, it changes it back to division. Okay, the subtle difference there, pretty commonly people try to look at this one and try to write natural log of 3x divided by 5. Doesn't work. You would have to have them ln 3x minus ln 5 for that to happen. Okay, so check it out. Super easy. Let's go step by step. The fact that there's a 1/3 in front of this means what? It became a power. So what gets raised to the power of 1/3? Love it. Natural log of 3x minus 5. And I'm going to add a second set of parentheses here because there's a little bit of ambiguity if I don't. Do you understand what I mean by that? We'll cover it in a minute.
You don't know which number it has.
First time. Darn it. Sorry, say that again.
You don't know which number has the power.
That is correct. If I write without that.
I thought I had way too bad.
Nope. I loved your comment. I can't tell if I'm taking the cube root of the argument or if I'm taking the cube root of the logarithm. That's unclear. Do you agree with that? Because one could argue reasonably that this is what I mean. Or one could argue equally reasonably that this is what I mean. These are different values. It's unclear. I will try my very best to not make it unclear. Cool. Or to make it clear, rather. I'm all fired up about that still, just for the record. Cool. Nothing happens here, so I'm just going to keep it. Natural log y cubed plus 1. Everybody feeling good still? Purely subjective, opinion-based. Would you like to keep this as 1/3, or would you like to change it to a cube root? You would keep it? I would keep it. Cool. What's happening between these logarithms? So careful. We will get there. Right now, what is written that's happening between them? Subtraction. So when you say they're dividing, love it, kind of. You need to be a little bit more clear with your language. Dividing where?
Straight down the middle.
In the argument. That's what I'm looking for. A common mistake. Does it help if I show you common mistakes, or is this just going to stick the mistake in your head so you try to make it?
Show the common mistake.
Okay. Pretty regularly. And we're going to try to avoid it. People will try to do this. And I understand completely why you would try to do this, because you're trying to divide because you see the subtraction. That, however, is not the quotient property. That's a different property that we learned yesterday. This is change of base. Only the arguments divide, not the logs themselves. Easy mistake. This is how you would evaluate log base y cubed plus 1 of 3x minus 5 to the 1/3, which is awful. No idea what it is. Can't tell. Okay, we're going to avoid this. This doesn't work. Instead, what do we say divides? The argument. What's in the numerator? 3x minus 5 to the 1/3. What's in the denominator? We're done. That's it. Really, really. Is this super challenging? It's weird to get used to, but if you remember those three properties and avoid some of the mistakes, the common ones at least, you'll probably be okay. I want you to do one more for me, and I'm going to set up some data to look at one more application of these that I'm not going to make you do. Cool. I like this one. On Bravo. This is ugly. 1/2 brackets natural log of x plus 1 minus 3 log base, nope, I'm sorry, 3 natural log of y plus natural log of 2x. One little comment I would like to make about this one. I could have instead told you natural log of 2 plus natural log of x. I've just already condensed one small portion of it. This is for you. Write me a single logarithm, or alternatively worded, condense this logarithm. And you're going to go one of two places. How many of you it felt natural to expand or distribute the 1/2 through everything? That was your first step. You can do it. If you do it, just keep in mind, everything in there gets a 1/2 in front of it, which means every time you write something, each step needs a 1/2 in your log of writing. I'm going to hold off until the end, only by preference. I'm only going to deal with what's on the inside to begin with. So here we go. The fact that there's a subtraction between these meant that what happened with their arguments? They divide. Now I'm actually going to do 2 steps in one. X plus 1 divided by, what should I write? Y cubed. I've done 2 properties instead of rewriting the whole line. I've just done this. All right? Plus what still? Natural log of 2x. Haven't dealt with the 1/2 yet. Don't need to yet. Questions, concerns? Okay, looking inside of here then, what else could be changed before I deal with the 1/2? Gosh, there's addition between these logarithms, which meant the arguments did what? They multiplied. I'm going to write this an ugly way for now. I wouldn't normally, but just so we can clearly see it. X plus 1 over y cubed times what? 2x. It's kind of ugly. Anything else we could do? Let me rephrase that. What else would you like me to do? Anybody? I suppose I could first add this bracket. Why subtract? I don't know who said it. How come subtract? Just out of curiosity.
I'm expanding.
Okay, natural issue. Yeah, 100%. I don't like the way this argument looks, just to be honest. And here's where we're going to get just a little bit of weird stuff. The 1/2 is the obvious answer. I'm going to write it as a square root and not change anything else. This becomes a natural log of, the 1/2 connects to all of this, right? So it's the natural log of x plus 1. I really don't like where that 2x is. Where would you put it? I would put it in the numerator.
Why didn't you just add it to the y before you did the...
Good. Love that that's your question. It's not connected to the y is one part of it. Because remember, divide by y cubed, then multiply by 2x. And that's what I'm trying to highlight here. It is much more natural, instead of having a fraction times a number, just sneak it into the numerator because we know how multiplication works. Over y cubed. This is a good place to stop. Could we go further? Only one more thing that's screaming, hey, do the algebra right now, please. What is it? The distribution. Could you? And would you? You probably don't know. Maybe you would, maybe you wouldn't. If we had to solve something about it, like if I was trying to find the domain of this function, which I know it requires that the numerator would be 0, because that would be a fraction, much easier to get if it's already in factored form. Pretty much any application that you can imagine doing, you would not benefit at all from expanding or distributing that 2x. This is where I would stop. Cool. Feels all right? Feels awful. What do you think? Okay. I'm going to give you some time to get some practice. I'm going to present one more thing here in a moment but I need a little bit more time to get that stuff taken care of. Question.
What's with the radical?
Instead of to the 1/2 power, I think it looks cleaner on a piece of paper to write the square root.
And the square root has it's been a while, but it cancels out the 1/2.
So I wouldn't say cancels. I'm using this property, which if you want to include it, this is like a recall property. X to the power of A over B, which this is one of the few situations where hate that A over and over. I will regularly write the fractions like this, but not always. Anybody remember what this changes to? It's the bth root of x to the a, like this, or we can look at it as the bth root of x to the power of a. They're the same thing. It depends on the situation. I'm sure I use one of them primarily, but for example, if I asked you guys to do 9 to the 5/2 in your head, how on earth do we do this? Do you know 9 to the 5th? Me neither. I know 9 squared. I don't know 9 cubed. It's 243. That's not though. That was wrong. It's 723 maybe. I don't know. I'm bad at math. Check it out. Mental arithmetic, just for the record. That's a hard way to think about it. But it works. This is square root of 9 to the 5th. I hate it. Can we change it so it's easier? What if we did it instead as the square root of 9 to the 5th? Do you know the square root of 9? 3. And you probably don't know what 3 to the 5th is, but it's a whole lot smaller than 9 to the 5th. Cool. Awesome. You get time for practice. We've expanded, we've condensed, we've laughed, we've cried. What else have we done? What? Really? Since I've started? I only noticed the one.
No, we didn't restart.
Oh. Well, that's exceptional. Are we done with it?
No.
Oh my gosh. Cool. You guys, oh my gosh, I love these problems. We talked about every concept needed. Did we do every type of problem that ever existed with logs though? Which means you're going to have to be a little clever. I assume I will not end the video yet because I think we'll probably have to do another one together. But here we go. Your homework this evening will be found on page 225. And this is homework 3.3, page 225.
You said it would be, what did you?
Homework, yeah. Cool.
But I think you also said 2.25.
I probably did. I am really struggling right now.
It's the absence of
Oh, it is taking so much more brain power than it should. At least 4 brain powers. Cool. You guys get to do the following. It's going to seem like a lot of problems. I don't know that it really is. It's a few. I want you to do 49 through 65 odd. But there's more. I also want you to do 76 through 82 even. And, I don't know. Start with those. I'll let you know if I add another one. Oh my gosh, there's true or false. Cool. You guys get started. I want you, this is going to be weird. I would like you to start with 59. Do that 59 through 65 first, and then go back and hit the 49 through 57. Start at 59. Read the directions. Cool. As you're doing that, I'm going to check the data. And that was a lecture. I'm going to say I'm done. 62. Let's do 66 because it looks harder. Check it out. 66 is not on your homework set. If you are like solid on 59, you can disregard this, but let's check it out. 66 says let's find log base b of the cube root of 3b. That's ugly. They're asking me to evaluate it. Read the directions for me real quick. Numbers 59 through 66 or 67, they tell me some stuff. I know log base b of 3, I imagine. What's log base b of 3? 5, 6, 4, 6. 5, 6, 4, 6. There's other information they give me, but I don't know that I need it on this problem. 5, 6, 4, 6. Okay, that doesn't answer it yet. Can we do anything to change this log, though? What's the power? It's not 3. 1/3. That moves out front. And then what happens within that root? They're multiplying, which means I can rewrite this as 2 logs that do what? They add. This is just the expansion of that other one. Do you guys agree with that? And rather than just do you agree, do you see where I pulled all this information from? These are just my log props. Check it out though. This is 1/3. Log base b of 3 was 0.5646. Plus, they didn't give me this one. Why would it be 1? B to the power of 1 gives me this argument of b. We can evaluate this log just with the given information. Cool. Have fun.